Welcome back. We have a problem here and it reads, a body of mass 9 kilograms rests on a smooth horizontal table. It is connected to another body of mass 16 kilograms hanging freely 80 centimeters from the ground by means of light inextensible string which passes over a smooth pulley fixed at one of the edges of the table. The string is taut. Determine the acceleration of the system, the tension in the string, the reaction on the pulley when the system is released from rest, the time taken for the 16 kilogram mass to hit the ground. Now, we have a diagrammatic representation of the question that we have just read. Here, we have the 9 kilogram mass that is resting on a smooth horizontal table, and we have the 16 kilogram mass that is hanging freely, and we are given the information that it is 80 centimeters suspended from the ground. If we should apply the knowledge that we have regarding connecting bodies, if this system is to be released from rest, the 9 kilogram mass, it is going to accelerate along the table, while the 16 kilogram mass is going to accelerate downwards. The force that exists in the string, we call it tension. Okay? What we can do as of now is to let the 9 kilogram mass be M1 and the 16 kilogram mass be M2. Now, to derive the equation for them, let's say for the 9 kilogram mass, which is M1, tension is equal to mass times acceleration. This is because the only horizontal force that can cause the 9 kilogram mass to accelerate along the table is the tension. Moving on, we can say tension is equal to M1A. So tension is equal to 9 times A. Tension is equal to 9A. We can call this equation 1. For the 16 kilogram mass, which we call M2, because it is going to accelerate downwards, it means that the weight is greater than the tension. So to find the net force will be weight minus tension, which is equal to MA. But we know that weight is equal to mass times gravity, so that will be M2G minus tension is equal to M2A. Substituting the values, M2 is 16 kilograms multiplied by gravity is 10 minus tension is equal to 16 times A. So 16 times 10 is 160 minus tension is equal to 16 times A is 16A. Now we can call this equation 2. So what we can do here is to substitute equation 1 into equation 2. Substituting equation 1 into equation 2, and equation 2 is 160 minus t is equals to 16a. Then we're going to have 160 minus t is 9a in equation 1. This is equal to 16a. So this will be 160 is equal to 16a plus 9a. 160 is equal to 25a. To find A, we divide both sides by 25. Then A is equal to 6.4 meters per second squared. Okay, and this answers the first question. So moving on, we can answer the second question, which asks us to find the tension. Using equation 1, which is tension is equals to 9A, tension is going to be 9 multiplied by A is 6.4. So tension is equal to 57.6 Newton. I can also use the second equation to find the tension. So whichever equation you use, you're going to have the same answer. All right, using equation 2, which is 160 minus tension is equals to 16A, that is going to be 160 minus T is equals to 16 times 6.4, which is the acceleration. So 160 minus T is equal to 102.4. So we can say 160 minus 102.4 is equal to T, and that is 57.6 is equal to T. Therefore, T is equal to 57.6 newtons. We can now move on to answer question 3, which asks us to determine the reaction on the pulley when the system is released from rest. So if we consider the pulley here, we have a force that is called the reaction F, and this is the force they are asking us to find. So if you look at the forces that are associated with the pulley, we have the tension, and we have F, which is the reaction on the pulley. To sketch that, we're going to have something like this, and this. So this is the tension, this is the force, and this is also tension. I can derive a triangle by sketching a line for F and using a parallel line to draw T. In that case, we have a right angle triangle where this side is T and this side is F. So when we take this triangle out, we will have our question 3, which is something like this, where we have the tension, we have tension here again, and we have F. So because it is a right angle triangle, to find F, we say F squared is equal to sum squared of the other two sides, which is going to be T squared plus T squared. F squared is equal to, the tension is 57.6, so that will be squared plus 57.6 squared. F squared is equal to 57.6 squared gives 3317.76. That will be added to another 3317.76. So F squared is equal to 6635.52. To find F, we send that as a square root 6635.52, then F is equal to 81.5 newtons. Moving on to the next question, that is question 4. It asks us to calculate the time that it takes before the 16 kilogram mass hits the ground. So if we collect our data, we know that it is initially at rest. So that means the initial velocity will be 0 meters per second. The distance between the 16 kilogram mass and the ground is 80 centimeters. That is 0.8 meters. We know that the acceleration is 6.4 meters per second squared. With this information, we can use S is equal to ut plus half at squared to find t. S is 0.8. This is equal to the initial velocity 0 multiplied by the time is t plus half multiplied by a is 6.4 times t squared. 0.8 is equal to 0 times t is 0, so I'll just move on to say half times 6.4 times t squared. 0.8 is equal to half of 6.4 is 3.2, then multiply by t squared. So I can divide both sides by 3.2 to have t squared. So 0.8 divided by 3.2 is 0.25 is equal to t squared. That means t squared is equals to 0.25. To find t, I will send that as a square root of 0.25. So t is equals to 0.5 seconds. That is the time it takes before the 16 kilogram mass hits the ground. Thank you very much for your attention. If this is the first time visiting our channel, please, you can subscribe, like, and share the video to individuals who could potentially benefit from our lessons.